Hello everyone. So yesterday we have seen how we can use Terraform. Okay. Uh, Yesterday on day 26. Okay, 26 of our 100 days of DevOps challenge. So there we have seen how can we use Terraform to deploy resources and all that. Let's take let's move ahead with that concept only. So IAC. So welcome to day 27, 27 of our 100 days of DevOps journey. So let's just understand this first. So why we use IAC? IAC provides us with a convenience that where we have left. Okay, we only have to start from there. Otherwise, in manual effort, if you forget something in between, you could not pinpoint. However, in this what we can say IAC, it is very simple. You just look at the code. Okay, this thing is missing. Just add this one and move ahead. Or this particular thing we have to update and then move ahead. So I'll just show you one thing over here. So this is draw.io. Yesterday we have seen some simple architecture about this. What we have more shapes, AWS, yeah, AWS 2024, plus 3D. Okay, so I have everything in here. So today we'll first create an architecture that would be uh, well configured according to our requirement. Okay, and right now I'm just explaining about AWS, and I'll explain the same thing with Azure also. Azure, and try to do it with GCP. So that you can have multiple options to explore from. Right now I just want management AWS 18 17. Okay, so we are just looking into this three-tier application. So what is three-tier application? Yesterday we have an idea about it, but today we'll just have something like we have a user with us. Okay, what will this user do? This is a user sitting over here. Okay, and there is internet. So this is the internet. Okay, so the user sends request to the internet. Okay, any yeah, sends request to internet. On internet we have our route 50 through route 53. There is, I think, route 53 robotics DNS network. So this is the route 53. Okay, what does route 53 provides? Route 53 is the DNS service. Okay, it provides the name server capabilities on that. So it comes to route 50 if we have bought some kind of like DNS domain or something. So it comes to route 53. Then what will happen over here is we have AWS cloud, AWS arrows. So this is my AWS cloud. So what do we have over here in AWS cloud? I'll just try to what are we having in this AWS cloud? Let us see over here. So in AWS cloud, we have like VPC, okay, virtual private cloud. It is the basic network component that we have deployed yesterday. This is AWS cloud, region. So yeah, VPC. So this is the VPC we have. First of all, yeah, there is one more thing that we need before that. Before VPC is the region. So suppose right now this is the region. Yeah, this is the region we have. Suppose we have this region. So uh, what do we have like region? This is region equal to US East 1. Let us suppose US East 1 we have. Okay, this is the region that we have created. Now what is the second part is, yeah, this is the VPC. Okay, this is the VPC. So as of now, I'll just keep it like this. Okay, this is the VPC. So VPC, what is the CIDR that we have provided yesterday? Yesterday we have provided the CIDR of like 1 minute equal to 10.0.0.0/16. Okay, this is the CIDR. I hope you all are able to see it. Let me just bold it. So this is our cloud, this is our region, this is our VPC, and in that VPC, what do we have in that VPC? We'll have where did it go? Developer, internet, machine learning, is gateway, this is endpoint. Yeah, this is the internet gateway. So internet gateway is the primary component that is responsible for allowing traffic to and fro from the internet. Okay, to and so yeah, here you go. Okay, so this is how it would be. So internet gateway we have configured. Internet gateway sits in like public subnet. So now there is now we'll be needing subnets. Not this one. Then resources, restrictions, groups. In this particular region, there are multiple availability zones. Okay, so let me just add it like this. This is availability zone A. Availability zone AZ equal to US East 1A, and let me just increase it. This is 1A, okay, and this one is 1B. Okay. For high availability, we should make resources redundant. So how would it go like this? So this is the availability zone, and now what we'll be doing here is we'll just create multiple subnets. Okay, here auto scaling group is outer part, private subnet. Yeah, this is private subnet. This is public subnet. So first of all, let's just create public subnet. Okay, so public subnet 1. This is public subnet. Public subnet, public subnet 1. What is the CIDR block? 10.0.0, 10.0.1, 10.0.0.0/24. Okay, this is the /24. Then just uh, 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 yeah, and this is public subnet 2. So one subnet is in AZ1, another subnet is in AZ2, and here just keep it like this. So what do we need over here? What do we need in this? So we'll be needing like uh, this is the public subnet, and we'll in VPC. So for network connectivity, we will be needing like route table. Where did it go? So this is the subnet. Yeah, this is the route table. Okay, let's just bring it between this. Okay, this is the public route table. Okay, public RT, public RT. I'll just keep it that way. Public RT. So public RT is getting all the like, and yeah, one more thing I need to add. It is auto scaling group. Yeah, this is the auto scaling group. What what is the purpose of what is the purpose of this auto scaling group? Auto scaling group. Suppose if we have the route table. Here we have kept the route table. I'll just put in this. What is it? So when you are trying to make like something for this, when you are creating a system design, it is also kind of system design. So you need to have a broader overview. Suppose you are suggesting a solution to someone. So in that case, it would be great help. It would be great if you have some tools like this handy with you. Okay. So this is the architecture that we have created. We have this particular thing, and in that auto scaling group, we have like EC2 instances. Compute. This is the compute EC2. Okay. Suppose some EC2 instances in this, some are in this. So what? And one more thing. So directly the data would not come directly to this one. So what do we need? We'll be needing in network. There is cloud directory, network, and content delivery. Elastic load balancer. I'll be needing application global accelerator balancer. So since this particular will work in HTTP HTTPS, okay, only web application level. So we can easily use this. This is the application load balancer. Okay, I just move for some of the. This is the application load balancer. ALB. I'll just mark it for that. ALB. ALB we have. What will ALB do? ALB will directly connect to these. Okay, these EC2 instances. These EC2 instances. Okay. it will distribute the traffic from these. So these are the EC2 instances. So all the traffic would be distributed from here, and we'll go like. So here we have created about the public subnet, okay, VPC public subnet, these two, and so this is how it would look like. So what I'll do here is today one very interesting part I'll just show you over here. So what I have done right now, just show you 1 minute here, this one. So I have created this 3-tier web app on AWS. Okay, so this 3-tier this repo I'll just update it, and we'll just commit the code in this one. Oh, sorry. Oh, just a moment. Yeah, here we are. I'll just close all of these. Okay, so here we are in 3-tier web app. I'll just rename it a bit. AWS. Okay. 3-tier web app. So a lot of things happen. I'll just, rather than this, what I'll do, I'll just create a new file. Main.tf we have created, and we have created variables.tf. Okay, everything we have created over here. What I'll do, I'll just create one more not folder, a file. I want to create a file over here. readme.md. So this is the readme.md hash 3-tier web app AWS. This repository hosts the Terraform. So it is also called it is all these files are called Terraform manifest files. Okay, Terraform manifest files for manifest file for deploying infrastructure to host a 3-tier web application. Okay, so this is all we have. Let's just save this. Let me just add one more file. I think, yeah. Okay, preview, it would look like this. Yeah, that is fine. I think license dot yesterday we have seen, right? Yesterday we have seen that best practices. Terraform. So this is the code base structure, security, backend, code base structure, and organization. Okay. So we need to add one version variable readme. Licenses not been added, so that is fine. We'll be following this structure only, and yeah, this is, so these are the locals.tf, main.tf, output.tf. Everything is provided in here. So yeah, we have created this git let's say git init. We have added like I'm going to add all these tf state backup. So for now I'm just keeping everything in here. I think there is we can ignore some of Terraform git ignore. Yeah, so TF state, yes, TF state files are kept, like, yes, these are some of the, 1 minute, I'll just copy this. You can find everything in here, like here, these are this particular git ignore, okay, GitHub git ignore. So you can find every template for like C, C++, Python, Java, JavaScript, Ruby, and Scala, Dart, Flutter, everything over here is available. So I'm just using this Terraform, okay, Terraform code, copy raw file. So sometimes what happens, TF state files get very big. This Terraform file, in this Terraform file we have all the modules available inside this. So all these things are not required in what we can say, in the GitHub repository. Okay, in any environment, when we create any particular environment, it will get created itself. So I'll just, so we have Terraform, terraform.rc. Okay, so I just want it over here. Okay, yeah, this file I want like I'm just unstaging all changes for now. Okay, and renaming it this particular Terraform git ignore. Okay, yeah. So now this Terraform, this TF state backup, all are out of what we can say. But we there is a requirement to save these TF state files. So there are also repositories for that. We can use HashiCorp Vault, or we can use S3 buckets. In my current organization, we use S3 bucket to for the keep safe of these Terraform TF state files. And with that, our code build and code pipelines are connected with that. So it uploads, it fetches from there. So everything is interconnected on that. So yeah, this is how I'll just add git add dot. Okay, I'm just everything, and we have okay, first commit, something is this copy paste, VPC deployed. Okay, VPC deployed. Yeah, uh, just keep creating a main branch, then we are all good, not good to go. Due to repository rule violation, failed to push some reference GitHub here aws.git. Okay, yeah, yeah. So the issue over here is this: it does not take. So okay, so that is how we should be careful. So there is alternative way for this. Suppose we can use, like we are using profile. Okay, so temp. Temp is the profile name. Temp is my profile name. So I don't really need like git add, git commit, git commit hyphen m secrets remove. So that's how advanced, like this is the security protocol again. Oh, okay. I think I need to delete that. Wait a minute. I need to push protection, resolve the following before. Access key, secret key. What I did is I just removed that code. Okay, yeah, I just removed the repository. I think oh yeah, origin is not configured. Now it should work. So you cannot save so it is a basic protocol. Okay, you could not save your like AWS secret key and access key and secret key in GitHub repository. So if you upload it forcefully, there are ways that you can upload it on the GitHub, okay, on the GitHub repo. But if the repository is public, right now I'm using public repository. So if the repository is public, then it will generate an alert across your AWS account. Okay, so account owner, your admin, they'll know. And I have seen such incidents when someone Someone used our organization's AWS account access key and secret key and created a public project with that. He was an intern in my previous organization. So at the time that account, that particular IAM account got blocked, and everything, we got the alert. So we have to like warn him, provide a warning and something like that. And we had some security sessions like to prevent any such kind of things. So always be careful. Right now all my code is in the repository. I can show you over here. So here you can find. So what today we just have seen some architecture yesterday and everything. So I'll just uh, I'll just show you one thing. Okay, today what we'll do, rather than developing on this this AWS part, okay, this Terraform. Okay, what we'll do, we'll look into another very important topic. Okay, very important topic means there is this called CI/CD pipeline. So what is CI/CD pipeline? Let's just jump on that. This is the basic architecture, so we can replicate it right away. But I'll just leave it for now. What, what is this? Oh, auto scaling group. What? No worries. This is the auto scaling group, and yeah, here we are. Okay, so everything is in place. Mm, so what is the CI/CD pipeline? How does it work? So I'll obviously I'll show you some demo with that, and for that we'll be using Jenkins. There are a lot of videos available on for Jenkins, but we have to create another resource. We have to set up another resource for that. So rather than that, GitHub Actions will use GitHub Actions. So here you can find CI/CD pipeline is like, suppose I'll just explain you in a bit. Developer, okay, dev dev user, let it be. Yeah, suppose this is my developer. Okay, this is my developer. Suppose I'm a DevOps engineer or developer, we can say. And what I'll just show you with a real-time example. Okay, GitHub. So this is my GitHub. This is my repo. This is my repository. The same repository that we have created right now. Okay, this repository, let's say 3-tier web app AWS. Okay, this is the repository. I hope you all are able to see this. Okay, so this repository, what will developer do? Suppose there is a cloud environment. Okay, this is local system. This is GitHub repository we have, and we have so this is the cloud infrastructure setup. So the code development is done on the user system. Code development is done on the user system, and that code is then published to the GitHub repository. Okay, this repository, it has been published. So what will happen next? Next is suppose on internet, okay, over enterprise network, not the internet, over the enterprise network, they have like computer. I'll just use computer for now. So suppose they have some kind of instances. Okay, some kind of instances on system, which is called runners. Okay, these are the runner. Right now only one runner. Let's just keep it only one for simple term. So what will this runner do? This runner automatically, so developer has uploaded the code over GitHub. So there are webhooks. There are the concept of webhooks and runner. So runner will check if the code is updated or not. And as soon as the code is updated, this runner executes the code and deploy this whole architecture. This whole architecture would be deployed using the Terraform code that we have created. So we'll set up a simple CI/CD pipeline. So this CI/CD pipeline, like there are certain stages for CI/CD pipeline, like a dev stage. Okay, here developer has provided dev, then scan. Okay, then it will scan like if there is any vulnerability or any defect in the code. If we say in terms of Python code or JavaScript code or any web application code. So what they have like dev stage. Okay, you have developed, then there is unit test, scan. Okay, unit test is done, then we have scan, then QA, quality assurance, if everything is working fine. Then staging, after staging, if everything is working fine on staging environment, then it goes to prod also have some deployment model like blue green strategy, or there are a lot of things going on. So CI/CD pipeline is basically to enable everything, okay, enable to automate everything inside this. And CI/CD pipeline, like CI/CD stands for continuous integration, so we have integrated this. And this part is called continuous integration. So as soon as the code is published to this particular GitHub repo, it will trigger the, so continuous integration and continuous deployment, then continuous testing also there, CI/CD, CT, continuous training in case of ML ops or AI ops we can say. So continuous training. So what does it do? I have used Jenkins, Kubeflow, and MLflow for these purposes. Mostly on Jenkins we have set up. So what we can do, we can set up like a threshold. I couldn't recall that particular terminology right now. So there are continuous training we said. So what happened here, we have set up a pipeline. So that pipeline is responsible for like provide the data to the to the ML code, and that ML code is creating a particular model. And we have training data, testing data. So if the testing, so continuous training and continuous testing both are integrated in that. So in that, what happened over there, so testing, training is done, model is created. Now the testing part came up. In testing part, we have a certain amount of 50% data we have provided to training, and 50% we have kept for testing. So with that, if the accuracy of that particular ML model is less than 80%, then we send it back to the training part, something like that. So we send it back to the training, and if the accuracy is acceptable, then we move it forward to the next stage. So that's how continuous integration, continuous deployment, continuous what we can say, delivery, okay, deployment, delivery. So continuous delivery is basically like if you have created one artifact, okay, so your artifact should be published in the repository, or in the what we can say, artifactory we can say. So that is continuous delivery. Continuous testing, continuous training, continuous monitoring is also involved in this. So that's how CI/CD pipeline is. It is mostly known as CI/CD pipeline, continuous integration, continuous delivery. Okay. So let's just create one. So how could we do that? So first and foremost thing is to set up a runner. Let me just open. Let me just start my virtual machine. Okay. So what do we have to set up here is, so first of all, let me just go to my repository settings. Just a moment. So we have so to enable that, what we have to do, just a moment, yeah. So we have to like settings, and there is, yeah, actions. Okay. So we have to configure a runner. So in runner, they provide new self. We are going to use this self-hosted runner. Okay, self-hosted runners. Linux, yeah. This is the architecture, and here are the commands that we need to run. Okay. Ah, so I think SSH, yeah, got it over here. So what we'll do, we will set it up. GitHub Actions CD action runner. So this is the tar file to configure runner. We can automate this part also, but for now just do it manually for understanding. Okay. Later on there is this tool called Ansible. Okay, Ansible can be used for used for setting up configuring these systems. Okay. So yeah, GitHub runner, and we have, okay, so this is a hash, and this one is, so it is unzipping config URL token. GitHub action runner authentication, self-hosted runner connected to GitHub. Okay, runner registration. Enter the name of the runner. Let's just say 100 days of DevOps. Could not find any self-hosted runner. Okay, no worries with that. And run.sh. Existing terminated error. Stop the service. Let me just retry it. Authentication. Enter the name. Press enter for default. Level. Enter any additional level. Okay, I think that is fine with me. So runner successfully added. Now it is working well. Enter the work folder. Yeah, settings saved. Now we just have to run it. Connected runner, listening jobs, using the self-hosted runner. Use this YML in your, yeah, it runs on. Okay, that is fine. So I think I should have, right now it is active, so okay, that is fine. So for this, how can we create, how can we test it out? Let's just go back to our, yeah, this run.sh, and after configuring the runner, just to ensure the runner starts automatically when the machine boots configure. Run.sh, initially config.sh, help version commit tokens in names. So as of now, I'll just run it like this. Check. So this particular step that I have followed, like where did yeah, this sudo svc dot sh install. So what did it do? I'll just show you. I'll just show you with example. Okay. So here env sh run sh svc sh. So I'll just show svc sh. So this particular file, this particular bash script is responsible for running the code even if when we restart the container. Okay, when we not the container, this particular virtual machine, when we restart it, it will automatically turn on the container. So I'll just show you one thing. Here we have created runners. I think runner, yeah, runner is right now not running. Here you can see right now it is showing offline. Okay, 100 days of DevOps. This is the runner, and here you can see self-hosted Linux and everything. So remove. Right now we could not remove it. We don't want to remove it actually. There are currently no running jobs. So yeah, here we go. Start. We have started this particular runner. Okay, and to set up what do we need over here? So I have created one simple script I used to test. So you have to create one directory. Okay, dot github. This is dot github directory we have, and in that we have workflows. Okay, and test runner dot yml. Oh, test runner rm hyphen rf. I want to create dot github. We are .github workflow, this. Okay, and in this particular file I want to create test runner.yml, this test runner.yml. So what did it do? Test local runner on push branch main self-hosted. Here you can see self-hosted is the tag that we have provided to the runner, and checkout code action use action 13 print. Yeah, so this is the print message that we have provided. Okay, so this is a very simple runner, and what we'll do, just save it, git add, git commit -m enabled testing GitHub Actions workflow. Okay, workflow, git push. So it is pushed. Now let's just see. So it is running. Yeah, here you can see. So starting job, setup job, completed test, checkout. Yeah, here you can see hello from the local runner. So this is how it looks like. Here you can see job test completed with result succeed. So this is how you can set up. And this is the testing part. Okay, testing part. Now suppose you want to create anything. So we have configured Terraform on this one. So how can we set up a CI/CD pipeline on this? So similarly we can do. So we have the first step is our this. So first prerequisite is completed. Okay, what is the prerequisite? That we have created our local GitHub runner. Terraform is installed. I'll just show you on this. Okay. So Terraform is installed on this particular system. Then contain GitHub repository. We have GitHub repository with our code. We have state management we haven't configured right now. So we'll set it up for S3 bucket or HashiCorp vault, or then there is secrets management. Yeah, secret store is very much important. So I'll just show you. So here you might know right now what we have configured here is I'll just copy one thing over here. Okay. So access key and secret key we could not set up on this on the AWS on the Terraform code. Okay, so rather than that, what we can do over here is we can AWS configure. We can just run AWS configure -- profile temp. Okay, profile temp is set up. To set this up, what we need access key, secret key, region. Okay, region, and fourth one is the type of output type. So that is not very mandatory part. What we can do over here is, so either we can configure this particular thing. So first of all, for secret manager we'll do it first. Let me just turn on my code cloud, playground AWS. So in the meanwhile it is starting, I'll just I have subscription, right? AWS launch. What is the issue? Start lab. Okay, so it is starting. In the meanwhile, what we can do, we can just create our code. This is the test code, so it will be running in the workflow. So you can create multiple different workflows in this same file. Getting node we have. Yeah, so what I'll do, I'll just create one new file name terraform.my. So first thing is, what is name we have to provide. What is the name? Terraform CI/CD pipeline. Okay, Terraform CI/CD pipeline. On means on which runner do we have to run? Oh, on what action do we have to? Then we have push. Okay, every time we push, on which branch? Like main branch. I'll just say I have a main branch already set up, or for pull request we can so pull request we can also configure pull request on main branch, and we can configure multiple different branch. So I'll just keep it for main once we push it. So if you want to test your code, like if it is working very well or not, so pull request is also pull request. Generally in production environments we use pull request. Otherwise, if anyone merges, okay, uh, anyone merges the code, we won't be knowing, okay, what changes are they pushing. So main, this is the what jobs do we have. Then we have on we have configured name. Okay, yeah, one more thing, every YML should start with this. Why is it cause in particular missing the jobs? Jobs is, yeah, jobs and this. So now the actual part, the execution part, jobs. Okay, what jobs do we have? Like Terraform is the runner. Okay, run on self-hosted. Okay, self-hosted, and steps. Now the actual execution steps. Wait a moment. Yeah. So let's just move it. So steps. What is the first step is steps like, yeah, and it is very like you should provide some comments. So like I want to use checkout. Okay, check out the code. This particular what is check out the code is checkout code intrinsic function. So yeah, let it use this actions checkout at the rate v3. Checkout at the rate v3. Oh yeah, I don't want this. So this is the step one. Okay, then set up Terraform. So Terraform init we need to run Terraform name, set up Terraform. Sorry, uses HashiCorp. Okay, so we have HashiCorp. So these are the plugins that you need to use. Or you can anyway, let me just show you how it has been started. GitHub runner. Okay, GitHub Actions, workflow, Terraform, automate Terraform with GitHub Actions. So you can find the documentation over here. Okay, that is circle CI. We don't have like GitHub account. We don't have Terraform account. We have AWS account available with us. Create new repository. Use this template. Sorry. Terraform plan. Terraform apply. Terraform plan. Request. HashiCorp TFC workflow. GitHub. Let's see. Let's just first run it. It will work, and it is fine. Otherwise, for today we can stop where stop right here. Like HashiCorp. I don't think. I doubt it would work, but yeah, because I do not have this HashiCorp account. Terraform at the rate v2 with Terraform. What is the Terraform? Security credentials. Create new access key. Part is configured with us. Terraform version do we have? Yeah, your version is out of date. 3 days version. Let us see. It will update it in some time. So let's just go back with Terraform version 1.10.2. All these with run, this run tag we use to execute the commands. Okay, all the commands goes with this Terraform init. Okay. I want like backend config. So I'll just set up this like this, okay, and then Terraform. We have Terraform format. Yeah, format check fmt name Terraform. Terraform format check and run Terraform fmt fmt hyphen check. If there is any particular, like if there is any misconfiguration or format is not correct, so this particular command will check and provide you. If you remove this particular check tag, so I'll just show you Terraform fmt. Okay, so right now nothing is off. Okay, Terraform fmt no color difference list false. Check if the input is formatted exited, so something like that. So right now nothing is out of format, everything is in check. That's why no error has been shown. Validate again, name Terraform validate. So it is good to like provide comments everywhere. Terraform validate, so that comments are provided so that everyone, if you are obviously working in a like in collaboration with someone, okay, whether it be a job, whether it be freelancing or anything, okay. So you should always provide you should always provide the comments so that anyone who uses your code next time will understand what has been done and from where we have to start. Okay, Terraform validate, and we have Terraform plan name. So there is one more thing. So what I need to do is, sometimes what happen, we just use this tf plan dot yeah, tf plan. Okay, I'll just create this plan, and this particular tf plan file will have all the plan that has been set up. Okay, then now what we'll do, right now we have created everything in single file, plan as well as apply. Okay, both of them are in single file, but ideally in while we are following best practices, plan and apply, both of them should be kept in different files. Okay, so that's how. Now Terraform apply. Okay, Terraform apply, then name Terraform apply. If yeah, if we have to set up, if GitHub event. Okay, if we have here we have configured the event right on top, we have configured the this particular event. Sorry, if GitHub dot event name equal to push. So this is the event name. We don't want to right now we haven't configured any secrets here. tf env. Okay, so right now we are not configuring any. Terraform apply, and yesterday we have seen auto approve, right? Approve, auto approve. This is where what we need to apply, the plan that is stored in this particular file, tf plan. Okay, so we are all good. Let's see if it will work or not. Okay, our test runner is configured, main.tf is configured, provider.tf, provider profile is temp. Let's see. Okay, Terraform ci cd created, sync changes. Let's just go back to our runner. Oh, yeah. And it might be possible that this particular runner get failed. This is plan. Cancel. I'll go back to CI/CD created. It failed 1 second ago. Test part is successful. Invalid workflow. Workflow is not valid. Oh, okay. I think this is I made this one. So if yeah. Yeah, here you can see actions. Let's go back to fixed in queue. So this is the Terraform. Named value and recognize. Haven't I configured it correctly? CI/CD created. CI/CD created. So this test workflow is working well. Only this particular test local runner Terraform CI/CD pipeline is getting failed. And it is, why is it getting failed? I think I should just remove this particular line. As of now, I'll just remove this. Here we go. Let's see. I doubt it would work, but because there is some plugin integration is required over here. But let's see. Test. No, I don't want to run test. Yeah, this Terraform CI/CD pipeline. Okay, Terraform init is failed. Terraform setup is successfully completed, right? I have made some self-hosted. Self-hosted we are running. Failed. This particular Terraform completed test job. Job Terraform is failed. Test. Self-hosted, run on self-hosted. Job Terraform. Terraform setup Terraform. It is getting failed. Let me just because this particular directory it is showing in the local system. However, it should not like Terraform CLI path. It is incorrect path. Let me just check it once. It is the right kind of node. Setup. After setup, I'll just add this line 20 in node installation configure. Let's see if it will work. Actions. Go back to actions. Test. Flow. Terraform. Setup job. Setup is running well. Setup Terraform. Setup Node.js. But 80. I think now it is working. Now it is working. So usage flow. So installation is going on, and let's just see. I hope it would complete. Yeah, here we go. So initialization also successful. We have format is also successful. Validate plan. Yeah, here you can see. So it is creating. It is creating a subnet. Plan apply is going on. Let's just quickly go back to our PPC console. Yeah, I think VPC is created. Yeah. Sandbox VPC is created here. So yeah, we are good. So yeah, this is how you can set it up. So job cleanup, and so this is a very important part in DevOps. You should know it. And GitHub Actions is something like you can use anytime. It is very easy to use. Okay, it is very easy to use. You can set up like anywhere, anything. I have used a virtual machine. You can use cloud server or anything. Virtual machine would be great. Even you can use containers. We'll explore more of these things. So right now we have our CI/CD setup done, and yeah. And one more thing, I just want to show you. So there is this. We can also configure manual triggers, so which will see tomorrow. I want to show you one thing, like here in DevOps CD action, yeah, action, then hyphen var 3 tier. main.tf. So there is one, I don't know where they have stored this temp pipeline actions ls underscore actions. Wait, 3 completed. Temp tool actions pipeline mapping. I think this tf state file is removed. Pipeline mapping temp. Let's check tf state tool. Okay, node tool was used. Okay, that is fine. Node tool is also fine. Find star.tf state. We haven't set up the state management right now, so there is one thing. There is HashiCorp init. Mm. I think the cleanup has deleted the tf state file. Tf state push. Terraform. Post setup node.js post setup post checkout condition post checkout. So we haven't set up the post checkout condition. I think tf state file is removed for now. So tomorrow what we'll do, we'll just use this state management. Okay, how can we manage the states and everything? How can we push? How can we manage the states? And so as of now, I'll just action delete this VPC. Yeah, so everything is deleted. I'll just stop. So yeah, there are multiple CI/CD options like Jenkins. I have used Jenkins a lot. It is very powerful CI/CD tool. You can configure it. You can use it for like ML ops. You can use, okay. You can use it for containerization, CI/CD pipeline. Jenkins is very, very, very powerful. But right now I just showed you this GitHub because it does not require too hefty setup. Because in Jenkins, I'll show you like how to set up Jenkins pipeline and everything. That is also we are planning to have. But this Jenkins pipeline is basically, it requires too much configuration, or yeah, in terms of customizability, Jenkins is best. You have a lot of plugins available. You can use anything. There is my Blue Ocean. We can integrate Ansible with it, and a lot of things can be done with Jenkins. So we'll see. Right now, I just showed you that GitHub Actions is way more easier when you are just using this something like this. Okay, simple setup. So yeah, here you. Let's reconvene tomorrow with another interesting topic. So thank you all. Have a nice day.